How do intermolecular forces affect the behavior of gases? Have you ever wondered why gases behave the way they do? The answer lies in something called intermolecular forces. These forces are the attractions or repulsions between molecules, and they play a big role in how gases act under different conditions. While these forces are much weaker than the bonds that hold atoms together within a molecule, they still have a significant impact on gas behavior. In a gas, molecules are constantly moving around, often far apart from each other. Because of this distance, intermolecular forces are usually weak and do not greatly affect gas behavior under normal conditions. However, when gases are compressed or cooled, these forces become much more important. There are two main types of intermolecular forces to consider. First, we have attractive forces. These forces pull molecules toward each other. When a gas is compressed, the molecules get closer together, and these attractive forces can reduce the volume that the gas occupies. This is different from an ideal gas, which assumes there are no attractions between molecules. On the other hand, we have repulsive forces. When molecules are very close together, they start to push each other away to avoid overlapping. This repulsion can cause a gas to occupy a larger volume than what ideal gas laws would predict when the molecules are forced too close. The balance between these attractive and repulsive forces is what influences gas behavior. At high temperatures, molecules have more energy and can overcome the attractive forces, making gases behave more like ideal gases. Conversely, at low temperatures or high pressures, the attractive forces become more dominant. This can lead to gases condensing into liquids or solids. Repulsive forces also play a role in maintaining the volume of gases. They prevent molecules from collapsing into one another, which keeps the gas from losing its volume. In the study of thermodynamics, understanding these intermolecular forces helps explain why real gases do not always follow the ideal gas laws. The ideal gas law assumes there are no intermolecular forces, but real gases show measurable differences due to these attractions and repulsions. There are practical applications for this knowledge. For example, when designing equipment for gas storage and transport, it is crucial to consider how pressure and temperature can cause gases to behave differently than expected. This understanding also helps in predicting condensation points and phase changes, which is important in refrigeration and various chemical processes. Additionally, knowing how intermolecular forces affect gas compressibility and viscosity can help in understanding how gases interact in different environments. In summary, intermolecular forces significantly influence the behavior of gases by causing deviations from ideal behavior. These effects become more noticeable under conditions of low temperature and high pressure, where molecular attractions and repulsions greatly impact gas properties. Understanding these forces is essential for applying thermodynamics principles to real-world gas behavior.